name is Michael Effiong Udo. I'll be taking you on chemistry for today on the topic chemical combination. In our last class, we have earlier talked about the electrovalent bonding, which can also be known as ionic bonding. Today we are going to emphasize on covalent bonding. And I would love to use the example of one of it, which is going to be carbon 2 oxide. Carbon 2 oxide is written as CO. Let's now see the type of bond that is common in carbon 2 oxide. There is this misunderstanding everywhere that people think that the bond common in carbon 2 oxide is a triple covalent bonding. It is not triple covalent bonding. We are going to find out that at the end of our today's class. Look at it this way. This is carbon. Carbon is having electronic configuration of 2,4. I love to use the valence electron. That is the electrons in the outermost shell. This is the 4 electrons for carbon. Reacting with oxygen. Oxygen is having electronic configuration of 2,6. I love to use the 6 electrons here, which is the valence electron. If this reacts, first come to look at the carbon. Carbon is looking for 4 electrons to gain a stable structure. Oxygen here is looking for 2 electrons to gain a stable structure. But if this one, that's the carbon here, if carbon brings 2 electrons, oxygen now contributes 2 electrons. You notice that oxygen will be stable because they are all looking for 8 electrons to be stable, but carbon will not be stable. Let's draw it out to see how this happens. This is my carbon. Here is the 2 electrons for sharing, while carbon still have its other 2 electrons left. This is the oxygen. Oxygen introduces its 2 electrons for sharing. This oxygen is still left with 4 electrons that is not used for bonding. Electrons that are not used for bonding are known as lone pair of electrons. In this case, carbon here is having 1 lone pair of electron, then at the side of the oxygen is having 2 lone pairs of electrons. If carbon introduces its lone pair of electron here, it may be stable, but that's so much like oxygen. Oxygen now said to carbon, no, don't introduce yours. Since I am having 2 lone pairs of electron, let me send one of my lone pair of electron to this place for bonding. If it sends it there, see what we are going to have. This is my carbon. Before now, carbon had 2 electrons, which is here. Oxygen introduces 2 electrons, which is here. This is my oxygen. Now 2 electrons have been sent in here. You can see this symbol indicating that this other electron here was contributed by oxygen, that none of these 2 was contributed from carbon. You can see the symbol, the sign that we use for carbon and that of the oxygen. In this case, this looks like a triple covalent bonding. But in real sense, this is not a triple covalent bonding. The 2 elements reacting must contribute equal number of electrons for the bonding. But in this case, carbon is giving 2. Oxygen is giving 4 electrons. But notice, oxygen did not just give the 4 at instance, no. It gave out 2 for normal bonding. It now decides to give out its lone pair of electrons. Let's come back again. This is still the 2 and here 4 electrons from the valence electron of carbon, and this is oxygen still having its 6 valence electron here. And when it reacts, whenever you write a bond like this, it stands for 2 electrons. So carbon now introduces 1 bond. Oxygen introduces another bond. That's why we have 2 bonds here. That is double covalent bonding here. Why is it covalent? Because they are sharing it. They did not donate or accept, but they are sharing it. That's why we call it covalent bonding. And it's double. Carbon is still having its 2 electrons that is not used for bonding. Oxygen is also still having its 4 electrons that is not used for bonding. Come to look at this. This is a lone pair of electrons. This is a lone pair of electrons. And this is also a lone pair of electrons. This oxygen is giving out its lone pair of electrons to this bonding. You look at this. This is not a triple covalent bonding. But what I have here is a double covalent bonding, and a coordinate bonding. If you don't want to call it coordinate bonding, you can call it dative bond. Now let's still continue to see another pattern that we can really use to explain this bonding. Let's use this one. This is carbon having an electronic configuration of 2, 4. Here are my 2 electrons, then the 4 electrons, 1, 2, 3, 4. Reacting with oxygen having electronic configuration of 2, 6. Here is the 2 electrons, and here the 6 electrons. 1, 2, 3, 4, 5, 6. If this reacts, this will bring 2 for sharing, and this other one 2 for sharing. I draw my carbon here, 2, then draw this other one. 2 is here. 2 is pending for sharing. We put that letter, and this is my oxygen. I have here 2, and the other oxygen. Here, oxygen introduces 2 electrons here. Carbon introduces 2 electrons. Oxygen is still left with 4 valence electrons. If you look at the side of the carbon, carbon is having 1 lone pair of electrons, while oxygen is having 2 lone pairs of electrons. Now, oxygen will be willing to give one of its lone pair of electrons for this bonding. If that happens, see what we are now going to have. Now, this bond that is common here, you may think that this is a triple covalent bonding because they are sharing 6 electrons. But in real sense, that is not a triple covalent bonding. Why is it not triple covalent bonding? Because if it's to be a triple covalent bonding, the 2 elements that are reacting are to contribute equal number of electrons. So the type of bond that is common in carbon 2 oxide is a double covalent bonding and a coordinate bonding. If I don't want to call it coordinate bonding, I'll call it dative bonding. My name is Michael Effiong Udo, a government school teacher in Akwa Ibom State. The government of Akwa Ibom State need the best for each citizen. That is why we made it possible that the teachers in the government schools are those who are qualified to be there. Kudos to His Excellency Governor Udom Emmanuel